हेलो एवरीवन, वेलकम टू कृष्ण केमिस्ट्री। मैंने इस चैनल 3 नवंबर को स्टार्ट किया था। इसे शुरू हुए लगभग 2 महीने हो चुके हैं। इन 2 महीनों में जितने भी वीडियोस मैंने किए हैं उनमें से ज़्यादातर पीएचडी इंटरव्यूज़ और मोटिवेशन पर है। अब सब्जेक्ट रिलेटेड वीडियोस शुरू कर रहे हैं। I hope you people will enjoy these videos. Now, this video is regarding chemical thermodynamics. This chapter is very useful for all competitive examinations, especially this class is the fundamental class of thermodynamics, basics of thermodynamics, right? So, this is very important if you are preparing for CSIR net, if you are preparing for GATE, if you are preparing for IIT JAM, IIT JEE, NEET, everything, for everything. This chemical thermodynamics chapter is very important. So listen carefully. If you have any doubts, please ask in the comment section, right? Okay, so the chapter here is chemical thermodynamics. Chemical thermodynamics. Right? Okay. So first of all, we have to discuss about 6 fundamental points. That is, what is thermodynamics? Okay. Then, why we need to study thermodynamics? These are very important, because if you want to study any chapter, right, without knowing the definition of that particular chapter is just like driving a bike without having a brake wire. It may lead to accident, right? So if you want to study any chapter in a very efficient manner, first of all you have to know what is the definition of that particular chapter. So we have to know 6 points basically. So those 6 points are, first of all, what is thermodynamics? Second, why we need to study thermodynamics? Third, what is universe? What is universe? Fourth point, what is system? Fifth, what is surrounding? Sixth, what is boundary? Right? What is boundary? These 6 things, first of all, we need to study, right? Okay, so first of all, what is thermodynamics? Simple, as the name suggests. Here, first of all, chemical means chemical reactions. Thermo means heat, right? Dynamics means applied force. What is applied force? You have to apply force to make some movement in a particular system. For suppose I am here, right? If you want to push me, you have to apply some force on me. By applying some force, if you apply some force on me, then I will move to some extent, right? So you are applying some force on me. So whenever you are applying some force on me, that means you are doing some work. So here, in place of dynamics, I can write work, right? I can write work. Now listen carefully. If you see these 3 terms, chemical, thermo and dynamics, so the relation between the chemical reactions, heat and work, the relation between chemical reactions, heat and work is known as thermodynamics. So we have to study about the chemical reactions, heat and work, the relation between them. This is simply known as thermodynamics. Clear? Okay. Now, why we need to study thermodynamics? In order to understand systems in a very efficient manner. I know you people didn't understand this. I will give you one example. First, suppose in our home one refrigerator is there, right? How this refrigerator works? It is taking electrical current, it is using some energy, and it is performing some work. To perform some work, how much energy this refrigerator is using, is consuming, we have to know, right? How it works, how much amount of energy it is taking, how much work it is doing, we have to know. So in order to understand systems in a very efficient manner, we need to study thermodynamics. Clear? समझ आया या नहीं? मैं सुन पा रहा हूं. आपने कहा कृष आप आगे बढ़ाओ, हम समझते हैं. ठीक है, मैं बिल्कुल आगे बढ़ूंगा, लेकिन आगे बढ़ते हुए we have to discuss about universe. We have to discuss about universe. Then what is universe? Simple. Universe means, in general term, universe means everything. Me is the part of universe, you are the part of universe, board is the part of universe, chalk piece is the part of universe. Universe is nothing but space. Yes or no? Yes, definitely. Universe is just a space. But in terms of chemical thermodynamics, universe means the combination of system and surroundings. Right? Universe means universe equal to system plus surroundings. Right? Universe means system plus surrounding. Then this system plus surrounding again, which is equal to everything. अरे यार देखो, under system, right? Specific part on the system, except me, everything is surrounding. If you consider me as the system, except me, everything is surrounding. This board is surrounding, this chalk is surrounding, this wall is surrounding, everything is surrounding. If you consider this board as a system, except this board, everything is surrounding. Right? Now surrounding plus system is nothing but everything. So I can write everything equal to system plus surrounding in terms of thermodynamics. Clear? So universe is nothing but system plus surroundings. Okay. Then after this we have to know what is the real meaning of system. In terms of thermodynamics, generally if you follow books, the definition of system is the specified portion of the universe is called system. What is that? Book definition: specified portion of universe is system. Right? Rest of the universe is surrounding. This is the definition of book, but we don't follow this, right? Generally write this definition only in your notes, right? But I will explain you what is system and surroundings a little more clear, right? देखो, I am taking one beaker here, right? Here मान लो water particles are there. This is water particles. Clear? This is water particles. Now this is my system. Now this part except this beaker, remaining everything is surrounding. So this is surrounding, this is surrounding, right? So this is system, this is surrounding. Then what is boundary? Boundary is nothing but real or imaginary line, imaginary surface which can divide system with the surroundings, which can differentiate system with the surroundings. What is this? See, this line or this surface, right, dividing this system with the surrounding. So this is called boundary. This is called boundary. Clear? Clear? See, if you guys are clear, I'm going to explain you a little more clearly again. Simple. मान लो this is system, right? This is surrounding, and this line which is dividing system with the surrounding is boundary. Clear? Clear? Right. Now this boundary is of two types. One is conductor boundary, one is this boundary is again two types. One is conductor boundary, one is insulator boundary. What is conductor boundary? Conductor boundary means which can allow heat to exchange with the surrounding. Okay, for suppose I am taking again this beaker. Now this boundary, if this boundary can allow heat to transfer from this system to surrounding and surrounding to system, this is called conductor boundary, right? This is called conductor boundary. If this boundary is not allowing to transfer heat from the system to surrounding, is called insulator boundary. Clear? Right. Okay. Now after this, very important thing, types of systems. Types of systems. What is type of system? Type of systems. Type of system. What is type of system? Generally, three types of systems we have. One is open system, second is closed system, third is isolated system, right? So first one is open system. What is open system? Open system means this system can exchange. I am repeating, can exchange, not transferring. Can exchange means this system can give heat to the surroundings, as well as it can take not heat, actually energy from the surrounding, right? That is open system. So what is open system? The system which can exchange energy as well as mass, or we can say matter, with the surroundings is called open system, right? For suppose I am giving one example, human body. Human body, right? Human body, right? So in this human body we are taking food. So whenever we take food, it will generate some heat in the body. It will generate heat in the body. That means we are taking some energy from the surrounding, as well as we are taking some matter from the surrounding. Matter is nothing but food here, mass, food here. So we are taking So this body is the system. This body is taking food from the surrounding. So because of food, heat is generating in the body, so that energy is also taking. Clear? Okay. Now it has to give, that is the exchange, right? It has to give, right? Now when we are doing some work, because of sweating, some heat releases, some energy releases to the surrounding. So energy is exchanging here. Now we taken food. This food will leave the body because of urine or in some other ways, right? That means matter and energy both are exchanging between the system and surrounding. So human body is the best example of open system. Human body is the best example of open system. This is the first thing. Next, closed system. So what is the closed system? What is closed system? The simple example, teacup with a lid. What happens? Because heat is there in the teacup, heat is there. You can experience, this teacup can take heat from the surrounding, as well as it can give heat to the surroundings. It can exchange. Why? Because if you touch the walls of the teacup, you can experience heat. So energy is exchanging. But because of the lid, because of some plate on the teacup, right, air particles are not going out, so matter is not exchanging, right? Matter is not exchanging. If matter and energy both will exchange, open system. But if only energy is exchanged but matter will not exchange, that is closed system. So teacup with lid or tea in a kettle are the examples of closed systems. Clear? Right. So after these closed systems, isolated system. It is very, very easy. So what is isolated system? What is isolated system? For suppose if you have the corona symptoms, doctor suggesting you have corona symptoms, so it is better to be isolated. What it means? You have to be isolated because you have the corona symptoms. That means you don't interact with anyone, you don't exchange anything with anyone, you have to stay in your room, you don't have to exchange anything with anyone. Yes, that is isolation. So in the same way, isolated systems also will not exchange anything with anyone, right? If you take the isolated system, neither mass nor energy can exchange between the system and surrounding. This is called isolated system. Then what is the best example of isolated system? Thermos flask, universe. So why universe is an isolated system, I will tell you at the end, but thermos flask is the isolated system. Why thermos flask is the isolated system? Example, thermos flask, right? Thermos flask. So why thermos flask is the isolated system? Because of thermos nature, because of the walls of the thermos container, it cannot exchange matter as well as it cannot exchange energy with the surroundings, right? So that's the reason why isolated system, the thermos flask is the best example of isolated system. Clear? Now in order to understand in a very, very good manner, I am going to give you some examples of open system, closed system and isolated system. If you can do these examples, you will get a very good command on this type of systems. Okay, see examples. So the first example, human body. This is open system, closed system, isolated system. Open system, closed system, isolated system. Human body. Second example, fan, air compressor, air compressor. Third, generator. Fourth, water bodies. Fifth, air conditioner. Sixth, what is the sixth one? Sealed balloon, expanded balloon, sealed balloon. Seventh, universe, expanded sealed balloon, universe. Next one, yes. Now tell me, human body is the open system. Okay, air compression. Generally, these air compressors we use in ceiling fans. Okay, so in these ceiling fans, these air compressors, generally we give electrical energy to run a fan. This air compressor can take electric current. That means it is taking some energy and do mechanical work, mechanical energy, and converting it to the kinetic energy because fan is running, right? So it is giving kinetic energy. So energy is exchanging. This is clear. What is about the matter? It is taking hot air from the surrounding and giving cool air. So air is giving, so matter is also exchanging, right? So matter is exchanging, energy is exchanging. So it is the example of open system. Okay, generator. What generator does? Simple. We are giving some liquid. Generally, generator will produce electricity, electrical energy. Then it is taking some chemical compound, right? It is taking some chemical compound. We are giving one liquid. I don't know which liquid we give to the generator to run, but it is taking some liquid, some chemical liquid. So chemical energy is converting into the electrical energy. So energy is exchanging between the system and surrounding. One thing is clear. Second, same way, it will take air and it will give air during the process, right? So matter is exchanging. So it is also example of open system. Next, water bodies. Water bodies means rivers, lakes, etc. Open system. It will take heat from the sun and it will produce vapors, right? So it will give heat. So heat means energy is exchanging, vapors are evaporating. So here matter is exchanging. So water bodies are the example of open system. Air conditioner. Air conditioner can take electric current and do mechanical work. That means it is converting into the kinetic energy. That means electrical energy converting into the kinetic energy. Energy is exchanging, but matter will not exchange in air conditioners, right? So this is the example of closed system. This is the example of closed system. Okay, next, expanded and sealed balloon. Generally, isolated systems doesn't exist in the universe, but normally, because if you see the expanded and sealed balloon, right, generally if you take, you can consider for some time, you can consider that air in the balloon for some time, but lifelong you cannot consider, because air will not exist in the balloon for lifetime, right? So generally isolated systems cannot exist, but because of the textbook we have to study, right? So this expanded and sealed balloon, I tied up the balloon. Okay, so that is the example of isolated system. Why? Because matter is not exchanging, because you tied the balloon, matter is not exchanging, energy is not exchanging. So this is the example of isolated system. Universe. So why universe is isolated system? Because universe is nothing but everything. It has no surroundings. It is the only system. In universe everything is system, right? If you don't consider me specifically, everything is system. If you consider me specifically, you accept me, everything is surrounding. If you take normal universe, in universe everything is system, there is no surrounding. When there is no surrounding, what's the question of exchanging of energy and mass between the system and surrounding? Okay, you cannot exchange, right? So universe is an example of isolated system. This is very important. Okay, universe, the question might come like this: universe is an example of, the first one open system, second closed system, third isolated system, fourth one none. Isolated system is your answer. Okay, so this is the today's class. Thank you so much for watching patiently, and if you like the video, please like the video, share the video, and subscribe the channel so that you will get the notification when I upload the videos. Thank you so much. This is Krish signing off.